Now we are ready to talk about how to do testing for tests. It's right on the glare. Watch this. Ready? You like that trick? All right. Two proportions. This question is specially worded to be tricky. Notice it doesn't actually say means or proportions anywhere. So if you saw this on an exam and you didn't have the title that you're testing two proportions at the top, how would you recognize this is a proportions question? Well, imagine you're the one collecting the data. You're asking people, what's your gender, male or female? It's 2015, you have to ask, trust me. And you would be asking them, do you prefer dog or cat? And they would say dog or cat. And why would people choose dog? Mostly because some people have an issue with having a pet that is smarter than them, and so they choose to go with a dog. We currently have a dog. This is a common discussion at our house. You know the little rule how you're supposed to feed a dog chocolate and they can't survive that? No, that's not true. Dogs really can eat lots of chocolate and survive. And that won't make it in the final cut. Mental note to delete this whole segment. All right, as we do a test of two proportions, this is different than the confidence intervals because of one thing. It has a null hypothesis that looks like this. That the two proportions for men and women are equal. And even if our null hypothesis was a less than or equals or a greater than or equals, there's still the assumption in the null that the two proportions are supposed to be equal. Now, if the proportion of men really was equal to the proportion of women, then if we took P1 minus P for one side, that would be the same as P1 minus P for the other side. And if we took both of these and we divided it by n, we're still getting the same thing because the null says those proportions are supposed to be the same. And here, those proportions are supposed to be the same. So when the null hypothesis says you're supposed to get the same proportion, it's also saying you're supposed to get the same standard deviation. And if we can use that, we can get better answers out of our hypothesis test. Now, the confidence interval did not have this. So we didn't worry about this for a confidence interval, but we are going to worry about it here for the hypothesis test. Let's fill out the starting. So let's fill out the rest of our hypothesis test with an alternative and an alpha. And here for our z-score, this is going to work the same way we've done it before. X minus mu over sigma. We're not testing x's, we're testing proportions. So we're going to put in right here the p hat for the first group minus the p hat for the second group, which should feel very similar to the way we did it when we were testing two means against each other. Minus, what do we think we're supposed to get? Well, they're supposed to be equal. So if you subtract them, 0 is what we think is going to go in there. And whenever you're testing two populations against each other to see whether they're equal, it's always a 0 here. What about the error? Well, your first gut instinct should be to do this. And notice all the no, X, wrong, because there's going to be some student who's going to scroll forward on the video, find this, and say, oh, there's my equation. No, this is wrong. And there's several things wrong. But let's start with this idea. We have the standard error from one group and the standard error from the other group. And we subtracted their proportions, so we might think we would want to subtract their errors here. But you must remember that you cannot add or subtract, because mathematically that's the same thing. And it even actually says that on the paper, but it's written small enough I don't think you can see it. Standard deviations, which is a little depressing because you would think we're stuck, and you can thank the normal distribution for that rule. But fortunately, it turns out you can add variances. So what I'm going to do here is I'm going to take this guy and square him, and this guy and square him, but I had the whole thing square rooted. So the square and the square root are going to cancel out, which is nice. Our equation's actually getting nicer instead of uglier. When you square things, this negative would be squared into positive. And this is still wrong because we need a standard error at the end, not a variance. And so a square root takes it back into variance. This matches what we had for the confidence interval. But notice we still have the no, the x, and the wrong because this is not right. We have not accounted for the fact that the hypothesis test had this extra information in there. It said you were supposed to get the same proportion every time. So if we could find some p bar is going to be a combined proportion of both, and put that in here, it would make it better and it would make it right. So here is our correct equation. If you're scrolling through the video without watching it and you're just looking for the equation, here you go, you found it. Except you don't know that because you're not listening to the video. I'm going to work on that piece of logic later. We've got a p-bar that shows up 4 different places here. How do we get that p-bar? I'm pooling, it's called a pooled proportion. I'm pooling the men and the women together, and so I want to take how many people said yes for the first group, that would be the men, and how many people said yes for the second group, that would be the women. I'm going to divide it by the number of men and the number of women. That is not the same as adding fractions. Adding fractions, you can't just add the numerators and add the denominator. Your math teacher would have a heart attack. Get common denominators. It's not what we're doing here. We are pooling fractions, not adding fractions. Pooling fractions means I take how many yeses for both groups divided by the total for both groups. And this p-bar shows up 4 different times in the equation. We now have an equation we can actually work on to actually do this test at some point in the future. Except next, I'm going to go edit out all that stuff that needs to be cut.